Today's topic is about PN junction diode. So, what do you mean by this PN junction diode? Actually, this is P-type substrate. This we can take it as P-type. P means holes, P-type substrate. And this we can take it as N-type substrate. So, this is P-type and N-type. That is PN. Junction is between this P and N is called as a junction. So, a P holes is taken and N electrons is taken. And this is anode terminal and this is cathode terminal. This is basically called as PN junction diode. Diode means that is going to convert AC into DC. Diode can act like an open switch or a closed switch. It can act like a switch, open or close. Diode can be used as a clipper, clamper. It has many applications. Diode can convert, that is the major application, can convert AC signals into DC. So now basically what we are going to learn today is what is this PN junction diode and what is happening when we bias it. These are the terminals they have, positive and negative terminal. And if we give biasing, biasing is when we give the voltage. What happens to this PN junction diode and what is the characteristics? VI, voltage and current characteristics. That's what we are going to see. It's a simple topic, basic topic. Now, normally, what is semiconductor? Semiconductor is like, suppose we can take, this is valence electron, valence band, and this is conduction band. In the valence band, the silicon is always having 4 as a valence electron. So whenever this valence band electron moves to the conduction band, then we say that the movement of charge carrier is called as the flow of current. Then only there will be a flow of current in the device. So this is normal silicon. So this 4 valence electron, if it is a very weak electron, there is a gap between the valence band and the conduction band. This is called semiconductor. There is a gap. It cannot move to the conduction band. So there is no flow of current. So we have to make this 4 valence electron to become a high energy and it has to go to the conduction band so that there will be a flow of current. This is the simplest way we can say. So what I am going to do in this 4 valence electron, I am going to Doping is nothing but it is adding of impurities. I'm going to add some more materials like P-type material. Here I have given in the PPT P-type material. P-type materials are called as trivalent. Trivalent and 3 valence electrons. That example we can take boron, aluminum. So here in this P-type, we are doping with trivalent, that is boron or aluminum. These are all construction details. Nothing to make it like it is very lengthy or something. It is all construction details. This is boron and or aluminum, any material you can take. So that is present in this p-type, that is holes. Because silicon alone cannot move faster. It cannot jump to the conduction band. There is no flow of current. But we want a material, we want a device. We want to convert AC into DC. So we are doing this doping process. That's it, very simple. And this is N-type material. N-type is consist of phosphorus, arsenic, antimony. N-type is nothing but pentavalent. Here I am putting 3 valence. Here I am putting pentavalent, 5 valence electron. All construction details. So when the question is asked what is PN junction diode, you have to write construction detail. What is P, what is N, what is dope. So these things you have to write in the construction. Okay. Now we got the material, P-type and N-type. And P is consists of doping of boron and aluminum. Now this valence electron 4 silicon got sufficient electron. Now it is going to share the electron and it is going to cross the junction. It is going to jump to the conduction band and it is going to make the flow of current. That we will see how the biasing is working. So this is our first slide. We'll erase the and we will go for the second one. Yes. Yes. Now, we'll go for the second slide. Yes, this is the second slide. Second, this is the symbol of the diode. I have shown the symbol of the diode, that P and N, which I have drawn, P type and N type, that has an international symbol. Standard symbol is there. So that symbol is, this is P type. The triangular shape is called P type, and this is called N. So this is anode, this is cathode. Simply a symbol we have, standard symbol, so that everybody should understand it. Okay, now I'm going to bias. The PN junction is forward bias when the P type is connected to the positive terminal. So this is P type. This P type I'm going to connect with the positive terminal, and this is N type. I'm going to connect it with the negative terminal. And for a clear picture, we'll go for the next slide so that you can understand that. So positive terminal of the battery and the N type is connected to the negative terminal. That is forward bias. Forward biasing is biasing by the same potential. When this is anode, positive, here also I am connecting with positive. So simple. And this is cathode, minus. So here also I am connecting with minus. So this is called forward bias. And the applied voltage is high. So we go for the next slide. We'll erase this, whatever I have. Now, yeah. Now you can see the picture. In this picture, N type, P type. So N type means it is minus. So minus is connected with minus. P type is plus, holes. Holes is connected with plus. So this is called forward biasing of voltage. So the PN junction is forward. Either or you can draw. You can draw NP or you can draw PN. But only thing is, if left hand side, if you have N region minus, then you have to connect it with minus. That's so this is biasing of your PN junction diode. When you bias the PN junction diode, what is happening? This is N and this is P, different, this is negative and this is holes. So this difference will get attracted each other. Different positives and negatives will attract each other. Same charges will repel each other. Different charges will attract each other. So there will be a mobility, there will be a crossover here. The junction is having a depletion region. Here they have drawn a very small depletion region. Depletion region is nothing but this is crossing the junction. Holes is getting attracted towards this electron. Electron is getting attracted towards the holes. So there is a depletion region formed in between this. So whenever there is a charge carrier movement, we have to increase this voltage. So when the voltage is raised, if it is germanium, we can take it as 0.3, and if it is for silicon, it is 0.7. So after that certain voltage, the depletion region will get break. And there will be a movement of charge carrier. So when there is a movement of charge carrier, there will be a flow of current. Very simple. So initially, I'm keeping a P type and N type. There is a depletion region formed between these two junctions. And there is, if we increase the voltage range step by step, the depletion region breaks and the forward current increases. And there is a movement of flow of current in the diode. So now the diode will act like a closed switch. As I said in the introduction, the diode can be a closed switch or it can be an open switch. So now it is acting like a closed circuit because there is a flow of current. There will be a flow of current inside this circuit. Very simple. Second one is reverse bias. Reverse bias means we have to change the bias. How to change the biasing? N region, N is negative. The negative region is given positive supply. So the negative region is given positive supply and the positive is given negative supply. This is biasing is reversed. Now what will happen? This positive biasing will attract this electron towards this positive. And this holes will get attracted towards this minus. Correct? because here the charges are same. So here the charges are different. So it is getting attracted towards here. So what happened? The depletion region is becoming wider. It is becoming wider. So as soon as when I keep on increasing the voltage, at the reverse bias condition, the diode cannot conduct. The diode will be not conducting in the reverse bias condition. So the depletion region will be keep on increasing. There will not be a flow of current inside this circuit. So this is the working principle of how the biasing is done for the reverse bias. Now, finally, we have to know what is the VI characteristics. VI characteristics, voltage and current. What voltage I have given and what is the current flowing in this diode. So that is the VI characteristics of both forward bias and reverse bias. That we have to see now in the next slide. This is VI characteristics. This is the VI characteristics. In this VI characteristic, this portion is called as the forward bias condition. This is forward bias condition. So when voltage is increased, this is forward voltage, the voltage in volts, and this is forward current, the current in milliampere. This is forward bias condition. So this forward bias condition when voltage is increased, for germanium it is 0.3 and for silicon it is 0.7. The diode starts conducting. There is a movement of migration of electrons and holes and the depletion region breaks and the forward current increases gradually. The current flow increases inside the diode. This is forward current increases. This is symbol of the diode. This is NP connection. And the reverse bias, what is happening? After certain point, if you keep on increase the voltage, it will go for the breakdown region. So this is the reverse current. Reverse current that is minus microamperes. In that there is a flow of reverse current. This is the simple characteristics, VI characteristics of the diode. Next we have to know what is the applications of diode. So these are the application of PN junction diode. It is used as a rectifier, AC to DC converter, voltage multiplier, over voltage limiter. So it can limit the current. If you connect it to the reverse, it can protect the circuit because it will not work in the reverse bias. The diode will not work. So it can protect the circuit by connecting in the reverse. So clipper and clamper circuit. How much voltage should be clipped or clamped? These are all the applications to be known for the PN junction diode, digital logic gates, solar panels, modulation and demodulation, AC to DC or DC to AC, adding with the carrier waves. So in the communication purpose, when the signal is of very low, weak signal, it cannot reach certain frequency. So they will add some of the wave. That is modulation. Again, they will demodulate and they will remove the weak signal and the added carrier signal. Such way, it uses in many applications of electronics. So, for you, I just want to say the basics about what is PN junction diode. I can say more elaborately also, but I want you to learn the basics. So, that's it about the working of the PN junction diode. Thank you.